Okay, at the end of the last video, we were working on example 1 of how to predict a redox reaction. And we had already gotten through a couple of the steps. We did step 1, list all the entities. We did step 2, using the table, classify each as a possible oxidizing agent, which you're going to write on the top, reducing agent, which you're going to write on the bottom. Okay, and include any combination. So if it's a combination, you would draw this bridge, and if I had left myself enough space, I would have drawn it above that OA, and then I would have put my SRA on top, and I'll do that in the next example to show you what I mean. I just didn't plan ahead. Now we were on step 3, what that said, choose the strongest oxidizing agent as indicated in the table. In other words, the oxidizing agent that's closest to the top of the table, and that's the MnO4 negative linked with the hydrogen atoms. It's third from the top, so it's much higher up than the potassium, which is second from the bottom, the hydrogen ions, and the water. And then and it says, and write down the reduction half reaction. So you don't need to try to figure out what it is. You just go to the chart and you write it exactly the way it is right here on the chart. Okay, so it's not like you have to come up with anything new. You're going to write it right off the chart. So you're going to write MnO4 negative aqueous, be good if I could see the chart, plus 8H positive aqueous plus 5 electrons going to Mn2 positive aqueous plus 4 waters liquid. Okay? So that's step 3. Step 4 says choose the strongest reducing agent as indicated in the table. So this time you're going to go back and find where those reducing agents are again and see which one's lower this time, because remember the strongest reducing agent is lower on the chart. So it'll be the copper when you find it. It'll be the SRA. And then it says write the reduction half reaction. So you go down here, and here's copper, and you write it this way, right? You have to start with what you have, and you have copper solid. So the reactant then is Cu solid. Okay, and its half reaction will be going to Cu2 positive aqueous plus 2 electrons. Okay, so now we've done step 4. Step 5 says balance the number of electrons lost and gained. So in the first one, the MnO4 is gaining 5 electrons, but the copper is only losing 2. So you're going to need to multiply this half reaction by 2, this half reaction by 5, and now there'll be 10 on both sides, and now we can add them together. So you'll have 2MnO4 negative aqueous plus 16H positive aqueous plus 5 Cu solids going to, and my 10 are going to cancel, so I'm not going to write them in, going to 2Mn2 positive aqueous plus 5 Cu2 positive aqueous plus 8 water. Now you might wonder why I didn't write the water there right away. Lots of times the water is usually the last thing written. It doesn't matter that it isn't, but I'm just kind of in a habit of writing it at the end. Okay, so there's our completely balanced half reaction. You can double check 2 Mn's, 2 Mn's. We have 8 O's here. We have 8 O's over here. We have 16 H's. We have 16 H's, 5 Cu's, 5 Cu's. If we add up the positives, negative 2 plus 16, so plus 14. Here we have plus 4 and plus 10 plus 14. Everything's balanced. We have one last step, which says predict whether or not the net ionic equation represents a spontaneous or non-spontaneous reaction. So now you go back to this chart and you put one finger on the MnO4 and one finger on the Cu solid, and you decide, is the oxidizing agent above the reducing agent, or is the reducing agent above the oxidizing agent? The oxidizing is above the reducing, and we know from the spontaneity rule that means it's spontaneous. So above the arrow you write spontaneous. Sometimes I just write spont because I don't have enough room to write spontaneous. And you're done. Pretty good. So I won't give you any of these tonight. Tonight I just want you to get used to using the table with these questions. Tomorrow we'll do a couple more examples and then I'll give you some. Okay?